is you can't forget this. You can't forget how to find the derivative of a function the old way, all right? Because you will be required. And we've got a couple other real favorite problems that we like to do using the official definition of derivative. But today, we have rules that I want to share with you that's going to make your life a lot simpler. Instead of using a half a sheet of paper to find the derivative of a function, most of you, if not all of you, will simply be able to look at the function and write down the derivative once you learn these differentiation rules. So, I begin with rule number 1. It is called the derivative of a constant. It says if f is the function with the constant value c, then the derivative of function f with respect to the variable x will be equal to the derivative with respect to x of your constant function. And that will always be equal to 0. The derivative of a constant is 0. So many people want to say that the derivative of a constant is that constant. So you got to get that out of your head because that's kind of normal. But the derivative of a constant is always equal to 0. Rule number 1. That means if y is equal to the constant function y equals 5, and I said, I want you to find the derivative of y with respect to x, you would simply tell me that the derivative of 5 is 0. The derivative of a constant is 0. Rule number 2, a big one, called the power. The power rule for positive integer powers of x. If n is a positive integer, n is a positive integer, the derivative of x to the power of n is equal to n times x to the n minus 1 power times the derivative of the base. The derivative of a power, and you'll use this one more so than any of the other differentiation rules. The derivative of the power rule says, take the power times the base raised to the n minus 1 power, and then multiply times the derivative of your base. Now, in the beginning, your base will simply be a single variable, and there will be no concern. But once we get into like wanting to find the derivative of the sine of x raised to the power of 4. I would still use my power rule, but I have to remember this part here. I got to remember to multiply by the derivative of the base. So eventually we will move on into that, but not in the beginning. We're just learning how to do this right now, so we'll try to keep it quite simple for you, okay? If I want to find the derivative of simply x, if I want to find the derivative of simply a variable, I got to think of this as x to the power 1. And the power rule says take the power times the base to the n minus 1 power, which gives me 1. But anything to the power 0 names 1. So the derivative of x is equal to 1 by the power rule. So if I have y equal x cubed, and I want to find the derivative of x cubed. Now before, we had to do this, okay? And that was not a whole lot of fun, especially when our power is greater than 2. But now all I have to do is apply the power rule. This simply says take the power times your base raised to the n minus 1 power. So in this problem we'll take 3 minus 1 times the derivative of x, which we've already shown you that's always going to be equal to 1. So that gives me 3x squared for my derivative. 3x squared. Now if you don't believe that that's true, I'm not going to do it. Go ahead. Use the pure definition of a derivative and work it out. You know, about that much work later, you got it. But the power rule you will use more so than any of the other rules. Rule number 3, constant multiple rule. Constant multiple rule. If u is a differentiable function of x, and c is a constant, then the derivative of c times u. Again, remember, c is your constant, u is the function. This is equivalent to finding the derivative of the function and then multiply it by the constant. That's all you're doing. You can put it clear out in front of your differentiation for the constant multiple rule. Real simple example, y equal 4x squared. The rule says I can take my constant multiple and put it out in front and then multiply that by the derivative of whatever the function is. So this is going to give me 4 times power rule, you take the power times the base to the n minus 1 power times the derivative of your base. So I've got 4 times 2 to x to the power, well, 2 minus 1 is 1, times 1, or to make a long story short, the derivative of 4x squared is simply 8x, without having to use the definition of a derivative. Things get much, much nicer. Sum and difference rules. This is rule number 4. And I think common sense tells you what it should be if I want to find the derivative of a sum or a difference. It goes like this. Rule 4. If u and v are differentiable functions of x, then their sum and differences are differentiable at every point where u and v are differentiable. That is to say, if I want to find the derivative with respect to the variable x of the sum of two functions, I'll call u and v, or I can kill two birds with one stone and also talk about the difference of the two functions u and v. The rule simply says, take the derivative of u, add it or subtract it with the derivative of v. The derivative of a sum or difference is equal to the sum or difference of the derivatives. That's all we're saying here. So when we come up with a problem such as, y equals x to the 4th plus 2x squared minus 3/4 x minus 19. I would not want to use, I erased it, my definition of a derivative to find that derivative. That would be rough. But I've got sums and differences, so I know, and you probably would never do this, but you're thinking to yourself, oh, okay, so I got to take the derivative with respect to x of x to the 4th. To that, I'm going to add the derivative of 2x squared, and then I'm going to subtract the derivative of 3/4 x, and then subtract the derivative of the constant 19. Like I said, you're probably not going to write that all out. In the beginning, maybe you will have to so you don't lose yourself. But as long as you're thinking it, we're okay. So, well, I've really got 4 little problems in one. Just do them separately. First thing I need to do is find the derivative of x to the power of 4. What is it?
4x.
No.
4x cubed.
4x to the power of
3.
Don't forget your n minus 1. 4x cubed. What is the derivative of a scalar 2 times x squared? 4x. What is the derivative of 3/4 x? 3/4. What is the derivative of 19? 0. And there you have it. Easy peasy. The derivative of a function. The slope of a curve. The slope of a line tangent to a curve. The instantaneous rate of change. The derivative. They all mean the same thing. Question. Does the curve does this function have any horizontal tangents? Question mark. I can't use a calculator. If a function has a horizontal tangent line, what would be the slope of that line? 0, right? All horizontal lines have a slope of 0. Can I find the slope of that curve? Can I find the derivative of that curve? Can I find the slope of a line tangent to that? Yeah. Differentiate it. So we've got, okay, derivative of x to the fourth, 4x cubed. Derivative of negative 8x squared,
Negative 16x.
negative 16x to the power of 1, plus the derivative of 2, 0. And if I've got horizontal tangent lines, then that derivative, then that slope has to be equal to 0, so I set it equal to 0. And I solve by factoring out of 4x, which leaves me with x squared minus 4. So 4x equals 0, x squared minus 4 equals 0, x equals 0, x equal plus or minus 2. So I say there's 3 horizontal tangent lines for that function. And I found it by simply finding the slope of the curve, finding the derivative of that curve, and setting it equal to 0. If I were to actually graph this quartic function, you come up with something that looks like that. Here's negative 2, here's positive 2, there's 2 horizontal tangent lines, and I missed the y-axis there a little bit, but at x equals, x equals 0. Now, I didn't state, or we did not even ask, what are the horizontal tangent lines for the function. All we asked was, are there any, and where are they located? That's all we've done. So we've got at x equals 0, at x equal plus or minus 2, I would have a horizontal tangent line. I don't know what the equation of it is without further investigation, but that's okay. All we asked was, where are the horizontal tangent lines located? Rule number 5, the product rule. Common sense would say, well, if I've got sums and differences, the derivative of a sum or difference is equal to the difference or the sum of the derivatives. It kind of follows in my mind that if I've got the derivative of a product, then that should be equal to the product of the derivatives. But that's not the case, okay? Here's your product rule for derivatives. And we're going to call this rule number 5. I have 2 functions, u and v. 2 functions, u and v. And I want to find the derivative with respect to the variable x of their product, u times v. In order to do that, I have to take the first function, the first factor of this product, and I have to multiply it times the derivative of the second factor. And then add to that the second factor, v, times the derivative of the first. The product rule for u times v. the first factor times the derivative of the second plus the second factor times the derivative of the first. A little more involved than what you would think for the product rule. So let's try to do one. I would like to find the derivative f prime of x if f of x is equal to the product of x cubed minus 4 x squared plus 3. The product of two separate functions. Now some of you are thinking, well, I don't need to know that product rule. All I have to do is multiply those two binomials together and then use the other rules that we have already shared with you, and that will absolutely work. But trust me, there's going to come a point in time when you can't multiply the two functions together. You have to know this rule. If you don't know the rule, there's no way that you could do the problem. So get used to it now. Again, the rule says I'm going to take the first factor, which is x cubed minus 4, and then I have to multiply that times the second factor of x squared plus 3. Then I have to add the second factor of x squared plus 3 times the derivative of the first. So that's going to give me x cubed minus 4 times. What is the derivative of x squared plus 3? 2x or 2x plus 3? No plus 3? Because the derivative of the constant is. And I've got my x squared plus 3 plus the derivative of x cubed minus 4. 3x squared. Now, it's just an algebra problem now. You got to get rid of your parentheses. So I've got 2x to the power of 4 minus 8x plus 3x to the power of 4 plus 9x squared. So that gives me 5x to the power of 4 plus 9x squared minus 8x. For the derivative of that product. And like I said, if you didn't have your rules and you had to work this out using the pure definition of a derivative, that would be tough. That would be extremely, extremely difficult. Next rule. Well, we've talked about addition and subtraction, and we've thrown in multiplication, and of course we got to have a quotient rule for derivatives. Rule 6. If I want to find the derivative with respect to the variable x of the function u divided by v, as long as v doesn't equal 0, of course, the rule goes like this. You take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and you put that all over the denominator squared. This is called the quotient rule for derivatives. Order makes a difference. If you start by taking the numerator times the derivative of the denominator minus denominator times derivative of the numerator all over the denominator squared, you'll be wrong every time. It's got to be bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. A couple years ago at one of our Saturday conferences, this guy from, gosh, I can't remember, it's some Christian school in Indianapolis. And he come in Crocs and hair down past his shoulders, and he's one of those free spirits. But, oh, is he ever smart. God, he's good. But anyway, he came up with this. He liked to sing to his class, you know. He'd sing things to them. That's never going to happen with me. But he came up with this little ditty to help students remember the quotient rule. And it's simply, you're going to take Lodi high minus Heidi low and put that all over low squared. Take the denominator times the derivative of the numerator, where in this rational expression we got the highs and the lows. We got the tops and the bottoms. So if we take Lodi high, I'm going to take the denominator times the derivative of the numerator, subtract Heidi low, where I take the numerator times the derivative of the denominator, all over low squared. And for some crazy reason, people remember that. Maybe it'll help you remember the quotient rule. So let's see how this thing works out. Oh. Function. I want to find f prime of x. If f of x is x cubed minus 4 divided by x squared minus 3. So my derivative with respect to x is going to be low d high minus high d low all over low squared. I personally haven't memorized the Lodi high minus Heidi low all over low squared. I remember the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay? Ugh. Well, I've got x squared minus 3, derivative of x cubed minus 4, 3x to the power of 2 minus x to the 4th minus 3, derivative of x squared minus 3, 2x. I would never, ever, ever, ever square out the denominator. I'm just going to represent it as being squared. What?
Where did your x to the 4th come from? X to the 4th minus 3. It's supposed to be squared.
Okay.
And at the bottom one is be x cubed.
Bottom, derivative of the
Oh.
top. Top,
X cubed.
times the derivative of the bottom. So, well, I screwed that up royally, didn't I? see, it's really easy to do. What?
Third term should still be x cubed. Put x to the fourth.
The third term.
The third.
You put an x to
term
the
anyway.
I
fourth.
did it, didn't I? Gosh. I think I'm leaving. I'm back. So you can see there's quite a bit of algebra involved. And you know, we're assuming that the algebra part you can do quite well. Hopefully you will. So what do you got? 3x to the fourth minus 9x squared. Here's where people usually get themselves into trouble because of the minus sign. They forget to distribute in both terms. In other words, I've got negative x cubed times 2x. I've got positive 4 times 2x. And I've got x to the fourth minus 9x squared plus 8x all over x squared minus 3 squared. You know, as an algebra teacher, I would then say, okay, can this be simplified? Make sure you put it in simplest form. I'm done. Now I can factor an x out of the numerator, but that's not going to help me with anything canceling out in the denominator. So clearly I can see that it's already in simplest terms. I gave you the power rule for a positive integer, where the power is positive. What happens if the power is negative? So we have another power rule called the power rule for negative integers. And it says n is negative, the derivative of the power, x to the power of n, but now n's negative, before it was positive. The derivative is equal to it's the same thing. It's the same thing. It doesn't matter if the power is positive or if it's negative. The power rule is the power rule is the power rule. You take the power times the base to the n minus 1 power. We know if y prime is equal to dy dx, the derivative of y. This is known as a first derivative. Now, if the derivative of your function is a function, or I guess I should say, if the derivative of your function is differentiable, then if I have, please note I used 2 little tick marks now. This is equal to the derivative of y prime the derivative of dy dx if the derivative of a function is differentiable. You can find the derivative of the derivative. This is called a second derivative. The derivative of a derivative is called the second derivative. Now, if the second derivative is differentiable, you could find the derivative of the second derivative, and therefore you would have a third derivative. Now, if the third derivative was differentiable, you could find the derivative of it, and that would give you a fourth derivative. These are called higher order derivatives. But the main thing that we're concerned with right now is you are able to find the derivative of any function that we can come up with. And there will be a lot more rules that we will share with you. But these are the basic differentiation rules that you need to know frontwards, backwards, and inside out. Your homework assignment for